All right, we're back recording, back recording. So, you guys been plugging away for a while. You guys have some good ideas. I'll show you guys what I would do for this, what I would do. Okay. So, this is the table that I would have come up with, and I'll walk you guys through the story of what I would measure and calculate. And so, you have different trials. You could have different passes, okay? Different passes. It does turn out that the math ends up canceling out. So, yeah, you could treat this as a variable, but what I would do instead is treat this radial distance as a variable, the distance from the center. Okay. And then you're allowed to know gravity field. You guys think gravity field matters? Um, guys, if you're on the moon, you think if you spin it kind of slowly, it's going to fall fairly quickly. But if you're on a planet with a lot of gravity, it'll stick a lot better, even if the coefficient friction is the same. And so you're allowed to know gravity, but I think that will probably enter into the equation. Okay. Now, what I would do is get a turntable as a visual here. What I would do is park this from the center somewhere. I would measure with the ruler. Okay, how far from the center is that? Okay. And start spinning this. Start spinning. Okay. Now, if you spin it kind of slowly, it's going to stick to the surface. If you spin it kind of medium, maybe it still sticks to the surface. You go faster, faster, faster. And some point slides off. You guys all slide off like that? Okay. Now, if the point slides off, what I would do is try to maintain constant angular velocity, okay, and then have one of my teammates pull out a stopwatch, and you measure. What you're trying to get to is how fast is it rotating, right? So these last few columns all build up to this one right here, right? So I would count how many revolutions it goes and how many seconds. Okay, like maybe you turn it 5 times and it takes like 4 seconds. Yeah, guys, one side of your paper you can have the table, the other side you can have the write up. Okay, that's good. Okay. Now, guys, when you break out the math and the equations, do a bunch of calculations, do you want your angular velocity to be in revolutions per second? Not for nice math. You really want radians per second, don't you? Okay. So let's say you did like 5 revolutions per, or whatever you do. Okay. How do you convert revolutions to radians? Times 2 pi. Yeah, there you go. So just multiply this by 2 pi, you'll get that. Okay. Okay. Now you can get the angular velocity in radians per second. And how fast your turntable is rotating at the point that it breaks friction, slides off, has something to do with this coefficient of friction. But so does the radius. So here, go back to some more trials. Okay. Okay, so this is parked really close to the center. Maybe not exactly the center, but offset by a couple centimeters. Do you have to spin it really, really fast or not fast at all for it to break off? I think this has to be going around really, really, really fast. Okay. But if it's right near the edge, do you think you could spin it a lot more slowly and it still breaks friction and slides off? Yeah. So okay, so some ideas there. All right, so okay. It said fuck around. I think you guys are kind of onto that. Here, I'll leave this up here for you guys. Okay, so again, you're doing lab write up on one side of your paper. This is the table I would have come up with myself to conduct this experiment.